Hi, I'm Eric Kang, a Senior Program Manager in Azure Data. In this module, we will learn about installing and running SQL Server on Linux in Docker containers and how we can apply this new concept in database DevOps practice. First, we will quickly go through an overview of database DevOps and Docker container. Then we will walk through the basics of running SQL Server in Docker container, deploying the container to Kubernetes cluster in Azure Container Service, and automate the end-to-end flow with the multiple demos. So, what is DevOps? DevOps is about people, product, and process that can easily collaborate together to innovate faster and continuously deliver the values. More specifically, or in a very practical focus, it is application, database, and the database CICD, which is a key ingredient in Agile DevOps practice. So this is very familiar flow. In application and also database CICD, it works like this. First, all those code for application and database is in code repository, like a GitHub, VSTS, and source control. Whenever there is a change in the code, it starts building and testing those changes. Once it is done, it deploys to target environment. It can be a test environment or production environment. Once it is deployed, we monitor, get feedback, and find the bugs. That goes back to the developers. The developer changes, fix, and enhance the application and database, and check in the code back into code repository. And then it repeats again. So, when we look at the DevOps in CI/CD perspective, also with the data perspective, what happens? We have a production environment and development environment. In between, we have a pre-production environment typically. So, in production and pre-production, we have a production data. And when it comes to development environment, we usually deal with the sanitized data instead of dealing directly with the production data. So, whenever a new sprint starts, let's say it's 3 weeks or a month, then in the pre-production, we create dev and test environments. That is consumed by developers in dev and test environment, and push the change. And then whenever there is a change in the code, there is a check-in test, which is a unit testing or any test that is necessary. So this part is called the CI. And it repeats during the sprint, and it can happen multiple times a day even. And when those CI integration is continuously done and we are reaching up to a sprint finishing, then we run the scheduled test. Once it is passed, then it goes into the deployment cycle. So in that case, we create a pre-production environment, and then we run the pre-production test, and then it pushed into a production side. So this is kind of a flow that we deal with in the DevOps CI/CD practice in data. All right, so let's jump into a Docker story, keeping that in mind. How Docker can help us enabling this CI/CD pipeline with a database application as a whole unit of development, test, and deployment. The first, the Docker container is providing us a benefit that is very fast to deploy. And it is portable. That means when we build and package up our changes in the Docker container, then it can be portable that runs on the dev and test environment, and then it can run on the pre-production and the production all same way without change when it travels through the different environments. And it's very predictable. That means if code is changed in the dev and tested, then it is guaranteed that the same code and then the change works in other environment as well, which is a very good benefit when we are dealing with CI/CD in complex environments. Also, when application and database is packaged up in the container, then we can easily build a high-scale and high-density container cluster platform using a container platform like a Kubernetes and Azure Container Service, AKS. So from dev perspective, it is very productive to work on the development and test cycles in the Docker container environment because of the portability and the predictability. And there is no more saying not reproducible bug case anymore. For operations perspective, it is very easy to have a control over the environment because the Docker container is based on an image which is immutable. From an ops perspective, they can configure and build Docker images for dev test production in an identical way. And that considers like application, SQL Server instance, runtime, dependent components all together. So wherever it goes through the portability, those defined set of application components travel together. And this synchronization can be fully automated. We are going to take a look at the CI/CD and DevOps perspective using container in this module. All right, so let's start with some basics first. So what is the key ingredient and the key commands that we need to know and understand to install and run SQL Server on Linux in Docker container? So this is a very basic starting point. You can start with the 3 commands. One is Docker pull and Docker run. Onset is I will actually go through the demo, like a hands-on lab style, so that you can follow me and then try it by yourself. And the third command is called the Docker compose. You can install this Docker compose tool on top of Docker in your the dev environment and the test and production environment, that you can package up multiple containers like a database application or unit testing containers all together as a single unit of application. Okay, let's take a look at the demo, and you can just follow and pause as you wish. What I have done is that I installed Docker on my laptop, and I have installed a SQL Operations Studio. And I have a Git cloned demo project, which is publicly available. In the reference slide, you can refer to how to clone this repository, and you can also follow the same step together. Okay, let's take a look at the basics.sh, which has multiple commands. The first one is pulling the Microsoft SQL Server Linux latest image from Docker Hub. So how Docker works is that it requires a Docker image which contains the baseline application. In this case, this is an MS SQL Server Linux latest version from the SQL Server 2017. All right. So simply, you can open up the command prompt. I'm pressing Control tilde, and then run Docker pull commands. Docker pull pulls image from repository, which is hub.docker.com in this case, and Microsoft account, and the image name, which is MSSQL-Server-Linux and latest version. For your project, you can use private repository, such as a private Docker Hub repository or Azure Container Registry that you can create in the Azure service. And you can pull your image from your private repository. So after you run this one, if I run Docker images, you can see all the images that was pulled from one of the Docker registry or Docker hub. Okay, once you have the Docker image, now you can spin up a container using that Docker image. So in this case, I'm going to call Docker run and name the container as a demo SQL Server. For SQL Server, there are important parameters that you have to provide. One is a port number. The default it is a 1433. I can change the port number to a port number that I wish. In this case, I'm defining the port number to 1431. And the next three is environment variables that you accept EULA and define the SA password and the addition of SQL Server using MS-SQL-_PID. Please note that for the demo purpose, I'm using the SA password environment within the command, but you should make it secure by defining it in the environment variables or something like that instead of putting it in your source code and check it in to a repository so that the other people cannot see your password information for SA. Okay, so the last parameter is defining that I'm running the container in detached mode. That means that it runs like a service. And I'm defining the image name that we just pulled down. So let's run this one. All right, so within a couple seconds after installing, downloading the image, if I run Docker PS, SQL Server is up and running. It's really fast, so developers or test environment can deploy SQL Server in a couple seconds after the image is downloaded. If you want to remove the server container, then you can run docker rm-f and the name of the container. So let's do that. Okay, if I run the Docker PS, then there is no server running. That is the basic commands that you can pull and run. Now, when you think about the development environment, what developers deal with is that they need to have a SQL Server running, and they need to have an application, and they need to have some test container that runs a unit testing or integration testing all together. Those all three, let's say, containers are a unit of application. So how we can easily compose those and run three containers or multiple containers as a single unit of deployment and the provisioning. So a tool that is called the Docker Compose actually helps you to do it really quickly. The requirement is that just to define those containers in docker compose.yml file. So let's take a look at quickly. So if you take a look at, this is a well-defined JSON definition represented in the YML format. What you need to do is define the containers called as services. And the one is MS-SQL and application. So in this case, I'm starting SQL Server and the web application as a single unit of deployment. So if I take a look at it, I have created a custom image of MS SQL Server that contains my database backup files in it and the necessary script that I often call. So I made up my own version of image and then uploaded it into a private repository that I have. And I have a container name, which I call it MS SQL. And same as the Docker run, I define the port number and then set the environment variables. For application side, it's the same thing. It's the same pattern. You define the image name and define the name of the container, and then define the port number, which is a web application. So I'm going to use port 80. So when we have this docker-compose.yml configured, from developer perspective, what developer needs to do is just to run docker compose up-d command. By running this one, also within a few seconds, all my SQL Server application entire environment that I need to run my dev actions are up and running, and then I can easily start my development and then the bug fixing, testing, all that action from there. All right, in previous hands-on lab demo, we went through a Docker pull, Docker run, and Docker compose. During that lab session, we actually saw I have created a custom image and then I started using it as part of my application and database. So it is kind of common practice when you are practicing the database development and application development in the Docker environment that you create your own image for your project and then build it and then push it into a public or private Docker image repository so that you can share that with your team, or that the same image is used to deploy onto a target test environment or pre-production environment or even production environment. So let's take a look at what we can do. So again, in this session, you just consider three things. One is Docker file, and the two commands, Docker build and Docker push command. Let's take a look at. Again, you can follow each step like a hands-on, so you can pause and start as you wish. I opened up the second file, which is a build your own .sh file. So it contains the two commands. Basically, building a Docker and pushing the Docker image is a very, very simple operation. It calls first Docker build, and here dot means defining the same location, which means the same folder, and I'm tagging it to my image name and the name of a repository. Okay, so to build a Docker image, what you need is defining a Docker file. So I opened up the Docker file. It is very simple definition. It has a pattern that always it starts from close, from command, which defines what is the baseline image of your own Docker image. So in this case, it can be Microsoft MS SQL-Tools latest version as my baseline image. Or it can be, if you're actually extending your MS SQL Server -Linux image by adding some backup files in it and the necessary components in it, you can start from that image, MS SQL Server -Linux and latest. So what I'm showing you is the pattern, how you can compose your own Docker file. And after you define your baseline image, then you can add multiple commands as you wish. First, work dir is defining what is a working dir directory when container starts. So it's more like a starting directory or folder when container starts. And there, I am copying restore.sql file, which is the sample example. You can copy entire folder or anything that you wish into the image, or you can even run any command. Like if you want to install more packages, like using apt-get, you can call run apt-get and name your package names there. So it can get installed along with the SQL Server and runs in the same container. The last command is the cmd that defines when container starts, what is the command that you want to run as a part of the bootstrapping of the container. So that is basically the simple definition of a Docker file. And let's try this one using our demo. So using that Docker file in the same folder, which is under AKS folder, I can simply run the command. Okay, so it basically takes the Docker file and using it as a spec or instruction, it builds a new image that is called Eric Escon /demo image and latest. And once you log in to your Docker repository or ACR using Docker login, then you can push the image into the repository. So if I run Docker push, then as you see, the newly created image is published into your Docker registry. Once Docker image is published into a Docker registry, then anybody who has access to the registry can pull down the same image. The MS SQL Server Linux image is built in the same way, and we have pushed into the Docker Hub so that you can run Docker pull and pull down the image. It's the same pattern, same way of working. In the previous modules, we have walked through the basics of using Docker and Docker container for SQL Server and any other application the deployment. So we learned Docker pull, Docker run, Docker compose, Docker build, and push for your own Docker image. In this module, we are going to learn about container platform. And let's start. So when you have a Docker images and the Docker container ready, then you can actually deploy that container into a container platform. So the container platform, a well-known one, is a Kubernetes. The key benefit of running containers in the container platform is that you can easily build a container cluster at scale with a very high density manner so that you can maximize the utilization of available resource that you have. And another key benefit is that the container platform manages the health and resiliency of the container. So if a container fails, then it checks the health and restarts the container automatically if you define it that way. You can run Kubernetes or OpenShift or Mesosphere container platform anywhere, but Azure has a service called Azure Container Service, which is very easy for you to provision and deploy and manage persistent storage for SQL Server usage. The key thing about the persistent storage is about the SQL Server needs to store its database files in that persistent storage. So remember that Docker container is ephemeral. So if Docker container is stopped and it's removed from a Docker engine, then all those data which was stored in the container itself is deleted along with it. So it is always important to store database files outside of a container, which is called persistent storage. So if you use Azure Container Service, then Azure Container Service has a built-in storage support, which is using Azure Disk. We are going to go through it together. And please remember, persistent storage is a key concept when using Docker container for SQL Server on Linux. So here, when we are dealing with the Kubernetes in AKS, Kubernetes has a command line tool which is called the kube control. And kube control defines a way that you can interact with the Kubernetes API very easily in the command line. And then you can also automate it using the command line tool. So here, the one key command that you want to and need to remember is kube control apply. Let's go through the hands-on lab demo and see how it works together. The first, I'm going to show you provisioning of Azure Container Service. Okay, so the requirement is that first install Azure CLI, the latest version, and the login using as login command. And if you have a more than one Azure account subscription, then set which subscription you are going to use to deploy AKS. In the subscription, there are three pre-requirements. One is a container service. The second one is Microsoft.compute. And the third one is Microsoft.network. So for these providers, you can call as provider, register command, and just to call these three. This is a one-time setup that you need to do. Once it is done, then just run as group command to create a new group that will store or Kubernetes and AKS related resources in the same group so that it's easier to manage. To do that, just to call as group create command with a name. We are going to name it as a MVA demo KS group and define the location. The location can vary based on your subscription and your preference. I'm going to use West US 2 as the region of Azure service. Okay, so once that is done, it's all prereq. Then the actual command is a one line to create Azure Kubernetes, Azure Container Service with a Kubernetes. So the command is that as AKS create and define the group name that we just created and name the cluster. We are going to name it as MVA demo K8S cluster. The next two commands are important. One is a node count. So because we are going to create a cluster of nodes that can host the multiple containers and load balance, so node count is important one. You can start with the 1, and you can increase using scale command later on if you need more. So I have a sample below for the scale command in that case. And the next one is that defining the VM size for each node. So if you define a node count 1, then AKS will provision one virtual machine in Azure using the pricing tier that you can define. In this case, I'm defining standard underscore D2S underscore V3 for demo purpose. You can scale up and down if you wish. So that is basically the key parameters that you need to provide for AKS create command in Azure CLI. So you can run this one. I already ran this one for the demo prep. It will take about 10 minutes or 15 minutes, and it's a pretty simple step that you can have entire Kubernetes cluster in AKS in that short amount of time. So once it is created, if you go to portal and the resource group that you have created, then you can see AKS provisions one virtual machine of the pricing tier that we defined and necessary network definitions. And it also provides the load balancer, which is very handy. I'm going to cover this one in the later section. And it defines the disk that is used by the node itself. Okay. Once that is created, to be able to access the cluster from your local machine or laptop, for example, using kube control, you need to have the cluster context in your local machine. So to do that, simply run this command as AKS get credential and provide the group name and the name of the cluster that we just created. Once you do that, then I will actually run the kube control command. Kube control can access all of these clusters, Kubernetes clusters, and set MBA demo K8S cluster as my default connection. So from now on, when I run kube control command, then it uses the credential that we just set as active one and the current one and use it to make a connection. So let's run kube control cluster info. Then as you see, it is all up and running, and now I can interact with the Kubernetes cluster from my own laptop. So this is a one-time prereq to set up a Kubernetes cluster in AKS, which is pretty simple that you can do in 10 to 15 minutes. Okay. Once you finish that one, then it is a real operation that you can deploy your SQL Server on Kubernetes cluster in AKS. So let's go through it one by one. Okay, so I opened up the deploy to AKS demo file, which is number 4. So what we are going to do is that first we are going to deploy a namespace. Namespace is just the regular namespace that you can group related containers within the same boundaries so that you can easily manage it. So you can just name it whichever you want. In this case, what you need to do is that you need to define those specs in a file called namespace.yml. Any file that you can define in the Kubernetes format. So in this case, I define the kind of resource that I'm deploying to Kubernetes is namespace, and give a name production, which is my selection of the namespace name. And I also have another namespace, which is a SQL DevOps that I want to provision altogether. So that is the first file that I'm going to run as a preparation of my environment. So if I run this one, okay, so namespace production and SQL DevOps are both configured and it's provisioned. To get the information from Kubernetes in AKS, you can use a kubectl get namespaces. Then you can see production and SQL DevOps are provisioned in there. Okay. So now to deploy the SQL Server on Linux running in the Docker container to Kubernetes, first thing we need to care about is dealing with the persistent storage. So we have a pvc.yml file that I defined persistent storage. Let's take a look at it briefly. The concept is that Kubernetes has a persistent volume and a persistent volume claim. So persistent volume is a pool of resource that you can use with the definition of persistent volume claim. So for example, in this case, I'm going to claim 10 gigabytes of space, and I will name it as a SQL PVC claim 1. And I put it in the production namespace. When I'm claiming it, the storage that I'm going to use is defined under storage class name, which is default. I'm going to explain what it means in a few seconds. And the access mode is read-write ons. So this is pretty much like the simplest volume claim for SQL Server running in AKS Kubernetes cluster. So let's first look at it. So to create a claim in the Kubernetes cluster, you simply run kubectl apply -f pvc.yml. That's what you need to do. I actually ran it before this session. So let's take a look at what has been provisioned. So as you see, SQL PVC claim is created, and it's bound with the PVC volume, which is automatically provisioned by AKS using Azure Disk, and the capacity of 10, read-write only, and storage class is default. Okay, and let's take a look at what the storage class means. If I run kubectl get storage class sc command, then you can see the available storage class, which defines the storage, which defines the driver for persistent volume, which is the definition of a storage class, which is in this case the default is Azure Disk, and another one is a managed premium class, which is also using the Azure Disk, but in this case it uses the premium Azure disk, which has a larger size and the faster I/O. So you can choose based on your need. So by defining the storage class for your persistent claim, you can automatically provision a claim for that one. In Kubernetes, there are more storage classes, like the NFS is one case, and you can deal with third-party storage classes that you like. And to do that, what you need to do is the deploy the storage class provisioner container into your Kubernetes environment and start using it by defining your storage class within the persistent volume claim definition, which sounds a little bit complex, but once you have the persistent volume driver installed on your cluster environment, then it's very straightforward after that. Okay, so once you have those persistent volume is defined, then now you can deploy SQL Server using that as your storage for data files. To do that, I defined SQL-statefulset.yml. Let's take a look at what it does. For SQL Server, I defined the pod type as a stateful set, and I named it as MS SQL, likewise other Docker container demo that we have went through today, and defined the namespace into production. So what is important in this case is that for SQL Server, I'm going to use the SQL PVC claim one that we just created as my volume for SQL Server, and I named it as a SQL volume. And I'm creating a container from the latest MS SQL Server Linux, name the container as MS SQL, open up the port 1433, and the same thing as we saw in the Docker run, defining all the environment variables there. In here, volume mounts is the location that we define on which folder in the container we want to use the persistent volume that we just linked up together. So in this case, SQL Server on Linux, data files and all those log files are located in -opt-MS-SQL. So entire folder we are going to mount to the SQL volume persistent storage. That means all the master MDF file, temp database, MSDB, and your user databases all along will use this folder, and it is stored in the persistent storage, which is outside of your container. So even though this container within the Kubernetes faces a health issue, and it is recreated in different nodes in the Kubernetes cluster, the data stays without losing all the contents, which is very important in that perspective. Once you define that it is a simple, just running kubectl apply -f and then the Kubernetes spec file in YML format. So let's run one by one together. Okay, first the command, I'm deploying the SQL Server database container into Kubernetes. In the second YML file, I deploy my web application. That's about it. And let's take a look at what happened. If I run kubectl get services command, it shows all those services that we have defined in the YML file and provisioned. In this case, as you see, MS SQL, which is the SQL Server database container, is running, and also web application is running. Because we are simulating this environment as production, what we've done is that we are not exposing SQL Server to public internet. So in this case, it is defined as a cluster IP. That means the MS SQL container is only available within the Kubernetes cluster environment. And any connection from outside of cluster will not be allowed to connect MS SQL. On the other hand, web application is defined to use load balancer type. That means that it automatically gets external IP. When we saw the resources for Kubernetes in Azure portal, we saw that the Azure AKS automatically creates a load balancer as a part of Azure service, which is a good thing. That one of the benefit that you get when you're using Azure service instead of you're building your own Kubernetes cluster in your own private environment, where the load balancer will not be available unless you set it up by yourself. So in this case, web application is running within cluster with this IP, but also it is exposed to public so that the users can directly connect to that IP and use the web application service as we wish. So that's basically what it happens. And the web application internally within the cluster access MS SQL and then operate the data operations using that communication. Okay, so let's try that one. Also, because we have deployed it now, if you go to the IP, then as you see, our application is now up and running within the Kubernetes cluster. So far, we have walked through the basics of Docker and then how you can utilize Docker container in the Kubernetes cluster in Azure Container Service. In this module, we are going to run through then how we can automate this end-to-end practice using Visual Studio Team Service. All right, so let's put together all these scenarios into automated CI/CD workflow together. So as we see, first, all our source code, including the definition of Docker files and the Kubernetes specs in YML, let's assume that it's all in source control, along with your database change code and the application change code within it. So whenever there is a change in source control, Visual Studio Team Service monitors the changes in source control. Once it is detected, you can automatically trigger a continuous integration build and ask VSTS agent to start the job. The job that VSTS agent execute is Docker build and Docker push that we already saw in our demo. The importance is that all those command line actions and scripts that we have walked through today is all automatable using Visual Studio Team Service and the Visual Studio Team Service agents. Now, when the new image with the source code change is built using Docker build and then pushed into Docker push, then it goes to a Docker image repository. In this case, we create new MS SQL image with my custom components in it, and web application changes, and the test runner all together. Once build is successfully complete, including push the image into Docker image repository, VSTS can detect it and start an automated deploy process. And when we do that, we can define it in the multiple workflow steps. So first, we deploy that changes to the event test cluster. As we saw before, we can use kubectl apply using the same spec, and then the images will be deployed to the event cluster as a Docker container running in Kubernetes and AKS. And we can define with a test runner running necessary unit testing or integration tests within the test and dev and test cluster. Once it is successfully done, VSTS executes the next step automatically or through the approval process and running the same kubectl apply command. In this case, it can deploy a MySQL database image or web application into a pre-production or production cluster. So this operation occurs whenever there is a source control change, or you can schedule it like running once per day or multiple times a day at a specific time. Let's quickly take a look at how it can be done very easily in VSTS. I opened up my Visual Studio Team Service project, which is called the SQL DevOps-container. To automate the process, first, you need to define a build definition for CI build. And for release, you can define a release definition in Visual Studio, which is very simple. I'm going to show you one of the build that was successfully completed in previous run. So here, if I look at the build definition, what it does is, first, it gets source from a source control. In this case, it was a GitHub, and starts a job, 3 jobs, on an agent, which is a Linux agent in the Visual Studio Team Service, which is a hosted agent that is automatically provisioned and then assigned to my project. The first step and the last step is basically calling Docker login so that my agent knows which account to use to build and publish my image. And cleanup is just get rid of the Docker images that was produced as a part of the build definition. So it's just to clean up the interim artifacts. So main thing is basically calling docker build and push.sh. It is same as the docker build and docker push command that we walked through in previous module. That's basically what you need. If you define all those docker, the build and push command in the command shell, then you can use it like a bash command and execute it. VSTS also provides a template for the same operation. So if it's your preference that you can use the VSTS template instead of using the command shell and run the bash command for yourself or PowerShell command for yourself. So if you type in a Docker, then you can use a Docker template to run Docker commands. And if you wish to run a Docker compose, then the VSTS also provides a Docker compose, the command as well that you can use for your CI/CD automation. For Kubernetes operation, VSTS also provides a deploy to Kubernetes template. So basically, it's calling kubectl commands, but it provides your UI interface that you can use to define what and how you are going to deploy your containers into Kubernetes environment. So which is very handy that you can use it on UI. Basically, the content of the configuration for deploy to Kubernetes are exactly the same that we have walked through using the kubectl apply commands in the previous module. All right, in this module, we have gone through multiple parts of installing, running SQL Server on Linux in Docker container, building your own image for SQL Server on Linux, and also deploying it into a Kubernetes, as well as automating it using VSTS. There are a lot of contents in this module. All of those scripts and the steps are uploaded into my GitHub project. So you can get that demo script and you can replay the same the flow by yourself. To do that, you will need to learn a little bit about Docker itself and go to docker.com website. Also download both the Docker and the Docker Compose tool together. For Kubernetes, you can go to kubernetes.io website and learn about more for the container platform concepts and the details. The recommendation is that start with the AKS, which has a very easy way to provision Kubernetes cluster on Azure VM services. And it's a very, very simple as just calling one command as we walk through together in this module.